larger samples than what was in my test tube, just for, so I could take my drop-wise stuff for analysis. I made batches for both ratios. I started with 5 milliliters of glycerol because I didn't need to make a whole lot. And based on my molar calculations, which I used density, I used the relationship of rho here equals mass over volume. Rho is my density. And that's how I was able to go back from grams to milliliters, because a lot of my stuff, even though my molar calculations and molecular weights give me answers in grams, I use this formula to get into volume of my liquid solution. So that's how I got all this, and it works out to be about approximately 9 milliliters for the 1-to-1 and 18 milliliters for the 1-to-2. Well, I mix the solutions according to my calculations, label my flask, and install a desiccant tube. And what I mean by a desiccant tube, it's a little piece of glassware. Comes over about like so. It's got a little globe here. And this tube here, this actually inserts down the end to the test tube itself. There's my solution. And we have a little bit of cotton here. And this is calcium chloride. Calcium chloride serves to remove the moisture. And so any air exchange we have there is going to be filter dry through that desiccant tube. So that's what I meant by my desiccant tubes. Place them on stirred overnight because I want to know that I had a complete reaction. So I put a stir stick in there, got them on stirrers, let them stir overnight. The next day you want to extract your benzene medium before you try to get your samples out. In order to do this, you can't just walk up and pour it out. You might pour your sample out, and plus you expose it to the atmospheric air. So we have a vacuum pump in there, and I took a tube, and pretty much in the tube we immersed it in an ice bath. It has 2 ports. You've got a large exterior tube and a small interior tube. And what you're able to do is take the vacuum pump through a series of hoses and connect this up. I wish I could have had you guys a diagram, but unfortunately I did not put one up. With the tube, you sink it in an ice bath, and you reduce the pressure inside the reaction flask, okay? And what happens to benzene, when you reduce the atmospheric pressure, benzene will evaporate off as a gas. Now, I didn't want to introduce the benzene into my vacuum pump because if it mixes with the oil, it will seize the pump eventually. It eventually will wear the components of the pump out. So what I wanted to do is collect my benzene, and I did that via the ice bath. So what I did is let it come back through, and I reduced the temperature to cause it to condense. Once I got my samples and everything, I collected those samples for the infrared analysis. We're using Fourier transform infrared analysis to do this. It's the Thermo Scientific IS-10. It uses the Omnic software, and it's Microsoft Excel compatible. Brand new machine. It came in last Thursday, and I got some training on it by the company rep, and then I actually had to train 2 other people on the machine. Pretty simple. Omnic's a Windows-based program, so it's pretty self-explanatory if you're familiar with any kind of Windows software. Same game, just different name. What this FTIR spectrometer, just to give you a little background on what they do. And a spectrometer is essentially an upgraded Michelson interferometer. If you've ever done the speed of light experiment or anything like that, basically after they conducted the speed of light experiment, we knew that if we took a mirror and moved that mirror, we could scan across all the frequencies of the wavelengths of infrared light. What happens is that multiplexing action there, it scans those frequencies and it causes molecular modes of vibrations. All molecules vibrate. All right, and if you can get behind them with their natural frequencies and drive them just a little harder, you make them shake, rotate, and wag, and do all kind of different vibrations. Well, these modes of vibrations show up on our spectrographs as peaks, and if you're doing absorbance, they show up as peaks. Transmittance, they're going to show up as little troughs. So this allows us to characterize the substance being examined. I mean, we have extensive libraries which we draw off of that people have already done surveys, and taken spectrographs of. And we can do a comparison of these, and the computer program will pretty much tell you what your composition is, percentages, and stuff like that. So it's a real good thing for figuring out if we've changed the identity of the compounds we're dealing with, or we just have a mixture in there. According to our analysis, I've conducted what appears to be at this point 2 successful reactions. However, I'm still in the process of analyzing my graphs because I conducted a 1-to-3 molar ratio experiment just for comparison. That 1:3 ratio is not going to be used. What we were trying to see is if that third ligand, if we could remove the hydroxyl ion from the third ligand of the chain. So I'm still in the analysis of those graphs. That's why I did not produce those, because I also want to gather more information prior to displaying and reporting. Mostly up to this point, it's been careful logging of processes, reactions, and resultants. Every step I take is a brand new step. None of this has been done before by anyone, so I have no prior work to follow on. So I'm having to really log my steps and be very thorough in the data keeping. I mean, I showed Tori my log notebook the other day, and I've been in 2 weeks, and I'm already halfway through my first log notebook. I'm anticipating by I'm done, I may fill 2 out. Because I am keeping quite an accurate journal of it. I have obtained IR samples for the constituents and the products. Obtained them for the glycerol, the triethylamine, chlorotrimethylsilane, and all that. Everything matched up to what it should be. I saw what I should see for those pure forms of the constituents. And as far as we could tell on the initial observations of the graphs of the reactive products, a reaction did occur. We're seeing different peaks in different places. I'm seeing the hydroxyls where I should expect those along those. The next time I do a report, I'll have those graphs and I'll analyze and show you guys where they're going to show up and what we're seeing. Now I'm ready to react them with my phosphorus pensulfide. I have my 3 solutions ready to go. I have a 1:1, 1:2, and another batch of a 1:1 that we use a catalyst in, so that we could see what will happen with the addition of the catalyst. It's currently under filtration, and I don't know if you've ever tried to filter anything like glycerol, but it takes days. So moving forward, I've obtained my samples in some vials. I've obtained samples in sealed vials. I'm going to be carrying those over to UAH for further analysis. He told me the protonometers machine, I'm not really sure what the name of the machine was. He just kind of said that yesterday. I was informed that we'd be doing this yesterday to carry to UAH. So sometime next week, I'm going to go flying with a couple vials over to UAH, get to walk into one of their laboratories, and he's going to try to get them to train me on that machine as well. So my next step personally is going to be react with phosphorus pentasulfide, get the observations and record my results, and then I'm going to do my IR spectroscopy on those to see what happened and characterize those molecules. Hopefully I'll have some good results for you next time. And that's pretty much it for my 2 weeks. Other than that, we're just at this point, I mean, everything's a very careful step, so we call this the completion of step 1. Step 2 is treating them with the phosphorus pentasulfide to see what happens there. If we're successful within the next week, we could be uploading the gold ions. He showed me the vial of the gold ions that we get to upload. It's $300 for a very small vial, so we've got to be ready to go. If we can upload the gold ions in the next 2 weeks, by the end of the program, we should be able to hand this off to the biology department and try to publish a paper on it.